So today we're going to look at 6.4, which is on graphing the other trig functions. So tangent, cotangent, secant, and cosecant. So let's think a little bit about what we do know about sine and cosine, and that will help us to think about tangent. We had a formula maybe a couple sections ago for tangent that allowed us to write tangent as a fraction of two other trig functions. Does anybody remember what tangent was equal to? Yeah? Cosine over what? Sine over cosine, yes. Tangent is sine divided by cosine. So that's our formula for tangent. Now, let's think about sine. Sine looks like that. Okay, if you graph it from 0 to 2 pi. From 0 to 2 pi, not including 2 pi, how many times does it cross the x-axis? Yeah?
3. Or do you count it as 1 because it's not including... Doesn't it include 0?
It includes 0, yes, but not 2 pi.
Okay, so then 2.
Yeah, so it really crosses it twice. It crosses here and here. And then the next time it crosses, that's really the start of the next cycle. So there it crosses twice per cycle. Now, what do we know about the y value when something crosses the x-axis? It's the y value of a coordinate on the x-axis. Yeah?
0.
0. So that means that the top of this fraction will be 0 sometimes. And wherever the top is 0, that's when the sine is 0. So tangent and sine are going to cross the x-axis at the same points. That's what I'm getting at. Right. Because the tangent will be 0 whenever the top of this fraction is 0. And the top of the fraction is 0 when sine is 0. So they cross the x-axis at the same point. Now, let's think about the bottom. Okay, cosine, we generally draw like this. How many times does cosine cross the x-axis per cycle? Yeah?
2.
That crosses 2 times. And again, we just said that where something crosses the x-axis, the y value is 0. So that means that there are points in the tangent function where the bottom comes out to 0. Because the bottom is cosine, and cosine can come out to 0. So what would that mean if you have a fraction and the bottom has numbers that would cause it to be 0? Yep. Undefined. And when you graph something that's undefined, what do you usually get? There's a few things you can get. But what's one thing you can get in a graph at an undefined value? Yep. A vertical asymptote, yes. Tangent is going to have vertical asymptotes in it. Tangent will have a vertical asymptote everywhere that the cosine function is 0. Does anybody remember what's the first place that cosine is 0? Yep.
Pi over 2.
Pi over 2. So tangent will have a vertical asymptote at pi over 2. And the other place that cosine is 0 in the first cycle?
3 pi? Or is it
Not 3 pi. 3 pi would be beyond the first cycle, because the first cycle ends at 2 pi right there. Yeah? 3 pi over 2.
That's what I said.
Oh, I thought you said 3 pi. Sorry.
It's okay.
Yeah, no, you're good. Yep, you were right. So these are going to be your first 2 vertical asymptotes in tangent. And these are going to be your first 2 x-intercepts. All right, so let's... so actually, we already said this. So the tangent is 0 wherever the sine is 0. And there are going to be vertical asymptotes when the cosine is 0.
wasn't gonna set it. I'm not going to.
Now, let's think about a value that's not at the vertical asymptote, but very close to it. Right? Pi over 2, if you try to take the tangent of pi over 2, you're going to get, it's going to say undefined. Okay, can't do it. Okay, that's a vertical asymptote. But let's pick a value very close to pi over 2. Let's do the tangent of, I'm going to put this in parentheses, pi over 2 plus 0.00001. So it's not pi over 2 anymore. It's just to the right of it. So what do you think is happening? If we go just to the right, the graph of tangent is going which direction? Down and heading towards what? It's heading towards negative infinity. Now, instead of going just to the right of it, where do you think the graph is going to head if we go just to the left of the vertical asymptote?
It's going to go positive infinity.
It's going to go to positive infinity. Okay? It's up at 100,000, a million. It's up at a million. So the graph, let me show you what it looks like. Okay, so that's what we just did. We just tested a value on each side of the asymptote. All right, let me zoom out a little bit and let's graph it. All right, so let's put in the vertical asymptotes. Pi over 2, 3 pi over 2. Pi over 2, 3 pi over 2. Where do you think the next one would be?
5 pi over 2.
5 pi over 2, yeah. The asymptotes reoccur every 180 degrees. Yep.
In the -2, right?
Yeah, and they go -2, yeah. What I'm going to focus on is just drawing what goes in one section, and it's exactly like sine and cosine. If you can see what goes in one section, it's going to repeat itself in every section. All right, so we know pi is where it's going to have a 0. So let's mark that. We know when we were just to the right of pi over 2, we were at negative infinity. So over here, way down, and we didn't test 3 pi over 2, but it would be the same as when we were to the left of pi over 2. So where do you think I'm going to be just before 3 pi over 2? Yep. Yeah, I'm going to be up at infinity. And the graph has to stay sandwiched between those two sections. So keep it very close to the asymptote. It starts to curve away. And then it keeps getting closer and closer to that side. And that's what the graph of tangent looks like. It's those repeated curves. So I can do tan x. Kind of see it? So we drew the first completely positive cycle. This one right here is the one we drew. So that's what tangent looks like. So the asymptotes, kind of wrote off to the side here. If you know where one of them starts, then all you have to do is keep adding pi to it, and you'll get another one. Okay? Or in other words, if you add 180, you get one at 0. You get one at 90, 270, and then just keep adding 180, or subtracting 180. Okay, and that's tangent. Now, tangent is sine over cosine. What's cotangent?
Cosine over sine.
Cosine over sine. So what happens with cotangent is everything flips. Okay. Wherever you had a 0 before, now you're going to have an asymptote. Wherever you had an asymptote, now you're going to have a 0. So let's look at that. I think I have cotangent, so I'll let you copy that, but then I'm going to delete that page so I can put the graph of cotangent right next to tangent. So cotangent is cosine over sine. So now everything is going to flip. Before, we had an asymptote at pi over 2. Now it crosses the axis at pi over 2. Before, it crossed at pi. Now, we have an asymptote at pi. So all the zeros and asymptotes switch. And the other thing we have to think about is how many asymptotes there are per cycle. It's really one, right? It's really just one. It can't be two, because if you call this like asymptote 1, 2, 3, and 4, we can't say that asymptotes 2 and 3 both belong to that red curve. Because if 2 and 3 both belong to the red curve, then what would you say for this blue one? Would you say 3 and 4 both belong to that one? You already said 3 belong to a different one. So each asymptote can only belong to one section at a time. It doesn't matter how you think about it. If you want to say like the asymptote to the left belongs with the picture, that's fine. Or if you want to say it's the one on the right. But each section only has one asymptote that belongs to it. Kind of like armrests. You can't say everybody can take 2, because then, well, what happens to someone else? Then they get none. You can't have that. They all have to have the same amount. Yeah.
On the test, how would you? Will there be a question to say what sections a line is on, or like is there a specific way you want us to say on the test or homework, like what each belongs to, like you said?
You'll see the kind of questions we're going to have. So not like that. No.
Okay.
Just understanding that there's only one asymptote per cycle. Kind of like understanding here that there's only 2 x-intercepts per cycle. There's not 3, because that belongs to the next one. Yeah. The other thing that's a little different about cotangent is the curvature switches. Tangent, if you take the derivative, well, when you get to calculus, you'll learn more, but tangent basically has a positive slope everywhere. Cotangent has a negative slope everywhere. Okay. That's a big difference between the two. Yeah.
What was cotangent as a fraction again?
Cotangent is cosine over sine. Okay, but they look pretty similar. Okay, so any questions on those two graphs? Tangent and cotangent. Okay. So if you look at, just look at one of them. It doesn't matter which one we look at. Let's zoom in a little bit. When we had sine and cosine, what was the length of a cycle if you didn't stretch or compress it? Yeah, it was 2 pi. You had to go all the way from 0 to 2 pi before the graph would repeat. Okay, here's 2 pi down here. Now, look at this graph. A cycle is from here to here. If you go beyond what I just drew, you're going to see a repetition. So, what's the distance between 3 pi over 2 and pi over 2? Yeah? 1 pi. That's a difference of 1 pi. So, one thing that's very different about tangent and cotangent is the length of a cycle is pi. It's not 2 pi. Now, can we stretch or compress that? Absolutely. But what I'm saying is if you don't, it's 1 pi. So when we did sine and cosine, we had a formula that said you could take like the sine of 8, or you could take the sine of 8 plus 2 pi. 2 pi. Same thing. No matter how many times you add, multiples of 2 pi when you're doing sine and cosine, it would never change the answer. So let's say I did the tangent of 5. If the cycle length is pi, what could I add to that and get the same answer again? Pi. Any multiple of pi. Yeah. You could do tangent of 5 plus 13 pi. Oh, that's right. I'll just do 3 pi. Any multiple of pi that you add or subtract will give you the same answer. And that's what that formula is saying. Now, you can't add like 1.5 pi. No, that's not a full cycle. You've got to add 1 pi or 2 pi. You can't go in between. And visually, adding or subtracting pi just puts you at exactly the same point, but on a different cycle. But still the same answer, same y. Any questions why adding or subtracting pi gives you the same answer for tangent and cotangent? Tangent and cotangent are kind of the weird ones. They're the only functions that have a cycle length of pi. Everything else is 2 pi. Sine, cosine, secant, and cosecant. All right, so we've done this so many times at this point, right? Transformations, they work exactly the same with tangent as they do sine and cosine. So hopefully, again, I didn't plan on going through them all again. We'll do an example. I guess I'll put that on the board in case you need it. But you can replace this function with any trig function. Sine, cosine, tangent, secant, cosecant. Doesn't matter. A is your phase shift, B is your horizontal shift, C is your vertical stretch, D is your vertical shift. No change at all. So, any questions on how the transformations work? So in this section, I may ask you more to describe what the transformation is. As far as sketching by hand, not as much. Most sketching is just going to be on the calculator at this point. Now, we had a formula to find the period of sine and cosine. It was t equals something. Anybody remember what the formula was to find the period for sine and cosine? Yep.
R over B.
It is something over b. B is the only letter that can affect the period. But it wasn't pi over b. 2 pi over b. Okay, this was for sine and cosine. Well, when we do tangent and cotangent, it's not 2 pi over b, it's 1 pi over b. In general, the formula for finding the period is always the original length divided by b. And the original length for tangent and cotangent is pi. Okay, so one thing I may ask you about is tell me where the asymptotes are in a function. So I'm going to explain to you now how can you figure out where the asymptotes are. And it's all based off knowing where they are originally. So you have to know for tangent, they start at pi over 2, and they repeat every 180 in both directions. For cotangent, the first asymptote is at 0, and they repeat every 180 in both directions. If you can remember that, then you can kind of figure out where they're going to shift to if you do a horizontal shift or period change. So in order to find asymptotes, this is actually for any trig function, because we're going to learn in a minute that when we do secant and cosecant, those have asymptotes in them as well. Sine and cosine are the only ones that don't. Okay, but if you want to find asymptotes, bless you, in any trig function, first step is find all the asymptotes in one cycle of the original. So for tangent and cotangent, that is one asymptote per cycle. And I think I make a chart that describes all this in a minute. Let me just check and see if I have the chart. I thought I had a chart. Oh, there's a chart somewhere. There it is. So I'm going to summarize all the asymptotes for you if you don't remember what they look like in the pictures. But the first asymptote, like if you were doing tangent, the first positive one is at pi over 2. So that would be step 1. Basically, look that up in the chart once I give it to you. Or just think of the picture in your head. Pi over 2. Next, you set that argument. So in our case, like if it was tangent, it would be pi over 2. You set that equal to the argument, and you solve. Remember, the argument is I think I got rid of it. Well, the argument is what's inside the parentheses. So if I had like tangent of 2x plus pi, and I wanted to figure out, all right, I started with an asymptote at pi over 2. Where is that asymptote going to move to? You would take pi over 2, and you would set it equal to the argument and solve. If you can solve that and get x by itself, that will tell you where the original asymptote moves to. And then, if you want to know where all the asymptotes are, well, it's easy once you know one of them. They repeat every cycle. So all you do is find that asymptote from step 2. So like in this case, it would be negative pi over 2 equals 2x. That's where the first asymptote in tangent would move to if you did that phase shift and that horizontal stretch. Now that I know that that asymptote starts here, I just have to say that asymptote repeats every single cycle. So how do you find the cycle? Right there. So the period of this one would be pi over 2. So this asymptote is going to repeat every pi over 2 radians left and right forever, or every 90 degrees. Okay, so step 1, you'll have a table in a minute. Step 2, you're just going to have to use algebra to get the x by itself. And then still kind of part of step 2, use this formula to find the length of a period. So the answer to this one would be the asymptotes occur starting at negative pi over 4 and repeating every pi over 2 radians. So you can add any multiple of pi over 2 and you'll get another asymptote. Okay, I'm gonna do a problem, much nicer and more organized as we go through. Okay, so this one it says find the period of tangent 2x. Well, we can do that. What's the formula for finding the period of tangent? Yep. Pi over b. And what's b in this case? Yeah, Joe?
2.
2. So that's your period. Now, this is not sketching by hand. It says find a window, find a complete graph that shows 3 full cycles. Okay. So if pi over 2 is 1 cycle, how big is 3 cycles? Yeah.
Wouldn't it be, since it's pi over 2 is 1 cycle, 3 pi over 2 would
Yep.
be 3 cycles.
3 pi over 2 is 3 cycles. Can somebody give me an x min and an x max that has a width of 3 pi over 2? And there's lots of answers you could give me.
In radians or degrees?
Well, we're in radians.
Okay.
So what would be a window that has a width of 3 pi over 2? Preferably the simplest one you could.
0 and 2.
Yeah.
Would be 0 and 2.
Well, 0 to 2 would have a width of 2. Yeah.
0 to 3 pi over 2.
Yeah, I would just do 0 to 3 pi over 2. It's definitely not the only window that's 3 pi over 2 units wide, but it's probably the simplest. Now, y min and max don't really matter because tangent goes up and down forever. So, -4 to 4, it's probably okay. Put in your graph, tangent 2x. And if we did everything right, we should see 3 cycles. We might break a cycle in half, the way we set up the window, but that's still 3 cycles. 2 full, and then a half and a half. So that window's fine. If you didn't want to break it into a half, 2 full, and then a half, what you could do is slide your window left or right a little bit. Does anybody remember how much is each tick mark in radians? If we don't mess with what the calculator does. Each tick mark is normally how much? Yep.
Pi over 2.
Each tick mark is pi over 2. So if I slid my window 1 tick mark, or not 1 tick mark, half a tick mark, I could make it so that the 3 cycles connect. What's half of pi over 2? Yep.
Pi over 4.
Pi over 4. So if I wanted to slide my window to the right, all I would have to do is, well, add or subtract pi over 4, it wouldn't matter. So if you take that and do plus pi over 4, that's going to shift the start a little bit to the right. And if you shift this one, it's going to shift the end a little bit to the right. And now I should be looking at 3 cycles. Yeah. And now they are connected because I just shifted the window a little. I'm not worried if they're connected or not. If it just says show 3 cycles, just show 3 cycles. Any question on that or what we did here? Okay. So looking at those 2 graphs, it says one of them is the graph of 2 tangent x, one of them is the graph of 5 tangent x. So you really have to know what the 2 and the 5 are doing. Which one is which? They're the same window size. So same x min, x max, y min, and y max. Same windows.
I think the one to the left is y equals 5 tangent x, and the one on the right is y equals 2 tangent x, because the way that the equation you show this work is that if you have like a very big number to the left of like the tangent or cotangent, it's going to stretch it. Like if it was y equals 100 tangent x, it would be like very stretched out, and if it was like y equals 0.5 tangent x, it would be like more like stretched out.
Yeah, so this one on the left is more stretched out. It's more of a vertical stretch. Think of that as if it was like a piece of metal and you started pulling on it more and more, the curve would start to straighten out a little bit. Okay, it wouldn't be as as sharp of a curve. So that one on the left is the 5 tan x, and that's the 2 tan x. So you might have a question like that on the test, where you have to look at a graph and match it up. Any questions on that one? Okay, so now let's think a little about secant and cosecant. So I already have the graphs ready, but what is secant? If you think of it in terms of sine and cosine, there's a way that we always get secant, because we don't have a button for it on the calculator. How do you calculate the secant? Yeah?
1 divided by cosine.
Right. And how do you calculate the cosecant? Yeah? 1 divided by sine. Now, we just talked a little about sine and cosine. Does the cosine ever cross the x-axis? If you graph cosine, will it cross the x-axis? Just like the one we did last week. If you draw the graph of cosine, does it cross the x-axis? Yes. What's the y value where it crosses the x-axis? Yeah? 0. So that means secant is going to have what in it? Based on the fact that cosine can be 0. Yeah? And in a graph that would show up how? Yeah? It's going to have vertical asymptotes. Same with cosecant. Now, before I even show you the picture, I want to think about the number of vertical asymptotes. How many times does sine cross the x-axis per cycle in that picture? Yep.
2 times.
2 times.
So there are 2 isotopes, which is right when it's crossing the x-axis.
Yep. So there's going to be 2 asymptotes per cycle for both sine and cosine. 2 per cycle. Different than tangent. Tangent is 1 per cycle. Okay, so here's what secant and cosecant look like. They look similar. They both have these kind of U shapes and N shapes.
One is basically a shift of the other.
Yep, we know sine and cosine are shifts of each other by 90 degrees. So are secant and cosecant. They are exactly 90 degrees off from each other. Yep. And for cosine, it crosses the x-axis at pi over 2 and 3 pi over 2. Those are your first 2 asymptotes. Sine crosses the x-axis at 0 and pi. Those are your first 2 asymptotes here, 0 and pi. Now, just to be clear, what is a cycle? What I'm putting a box around? This is 1 full cycle. A cycle for secant and cosecant is a full U shape and a full N shape. And how many asymptotes are there per cycle?
1.
2.
2. Right. So this would be like asymptote 1, 2, and 3. You could think of it as asymptotes 1 and 2 belong to the box in black. Asymptotes 3 and 4 would belong to the box in red. And again, this is something I'm going to summarize for you in a table in a second. Pi over 2 and 3 pi over 2 are the first 2 positive asymptotes for secant. And the way you can remember it, it's the first 2 places cosine crosses the axis. 0 and pi are the first 2 asymptotes for cosecant. It's also the first 2 places where sine crosses the x-axis. But what's different about this graph compared to tangent? tangent does something that these graphs don't. These graphs never what? They never cross the x-axis. They can't. Because the formula for them is 1 over cosine. If you take 1 and divide by anything, will it ever equal 0? No. So secant and cosecant cannot equal 0. What was the period we said for sine and cosine? The regular standard period? Yep. 2 pi. That's also the same formula to calculate the period. So you always use 2 pi over b to find the period. Unless it's tangent or cotangent, then you use pi over b. Yes?
Notice that the isotopes are always going to be 1 pi away from each other.
Yes, the asymptotes will repeat every 180 degrees in a standard secant and cosecant graph. Yep. And again, do you have to memorize that? Not really. If you just know the first two, you can always just look at them and say, oh yeah, 0, pi, they're pi apart. So yep, asymptotes are always pi radians apart. Alright, so it can be kind of hard to remember, like, oh yeah, okay, so tangent, first asymptote is at pi over 2, cotangent, first asymptote is at 0. I mean, you can memorize it, but you can also use this table to try to remember. So this table is going to summarize all of the asymptotes that you get in the first positive cycle, or 0. So for tangent, the very first positive asymptote is pi over 2, and for cotangent, the first one is 0. What were my first two asymptotes for secant? So think of it, okay, secant is 1 over cosine. Think of the first two places cosine crosses the x-axis. Let's see. Yep.
Is it pi divided by 2?
And?
3 pi divided by 2.
Yep. So I never memorized that. I always think back to like, okay, what's secant? 1 over cosine. And then, okay, I know what cosine is. That's how I figure it out. And then what you're doing on the right is you're just saying, well, that asymptote is going to repeat every period. How do you get those values right there? Those come from step 2. That comes from step 2. Okay, so we'll practice that. And what about my first two positive asymptotes for cosecant? Think of cosecant as 1 over sine. And think of the first two places sine crosses the x-axis. Yep.
0 and pi.
Perfect. 0 and pi. So again, when you do a transformation, you got to figure out where those first two asymptotes shift to, left and right, and then tell me how often they repeat. Does everybody have the tape? Okay, so I'll leave that up there. All right, let's try finding domain, range, period, and asymptotes for secant. Now, this is just a regular secant, no transformations at all. All right, let's start with the vertical asymptotes. For secant, what are your asymptotes that we start with for secant? Yep.
Pi over 2 and 3 pi over 2.
Yep. Pi over 2 3 pi over 2. Now, those aren't the only two. Each of those asymptotes is going to repeat in general. How often? You could use a general word.
Every period?
Yeah, every period. So we have to figure out, okay, what's that period? So we're kind of thinking of like, this is like, say, the odd asymptote, and we're figuring out how often it repeats. And then we're going to figure out how often the even asymptote repeats. Okay. What's the period of the secant function? Well, Max, what's the period of secant? Yeah. 2 pi. So to find the period of secant or cosecant, it's 2 pi divided by b. In this case, b is 1 because there's no number in front of x. So this asymptote repeats every multiple of 2 pi. That's how you write it. And it's vertical. So usually we put x equals. All right. How would I represent that other asymptote repeating every 2 pi? Yeah.
For the other equation would be x plus 3 pi over 2. I mean, x equals 3 pi over 2 plus 2 pi n.
Yep.
I mean,
And that represents that asymptote repeating every 2 pi. So those are your asymptotes. Now, once you know the asymptotes, you kind of know the domain. In general, the domain would be everything except what? The asymptotes. The domain is all real numbers except the asymptotes. Now, if you got the asymptotes wrong, then you just got the domain wrong with it. But if you wanted to spell it out, you could say the domain is all real numbers except any numbers that fit that pattern or that pattern. And you could write those out if you wanted to, but since we have them right above, I'm just referring because they're right above. So that's your domain. Let's do, actually the period, we probably should have done the period first because we needed that for the vertical asymptotes. What was the period? Yeah. Period was 2 pi. Again, do that one first. And the range. Okay, let's go back and look at secant. Okay. What does it look like the range is for secant? Yeah.
sure.
You have to do like where it's like up to negative, like it's negative infinity to negative 1.
Yeah, negative infinity up to negative 1.
And then it's like using that it's positive 1 to positive 2.
So your range is basically everything except negative 1 to 1. So it's negative 1 and down and 1 and up. So let's write that as an interval. So negative infinity up to, and you do include negative 1 because it hits it. Or 1 to infinity. Any questions on that? That's for secant. Now let's look at the graphs again because I think the next question is to describe cosecant. Well, is there anything that would stay the same when you were describing those four things between secant and cosecant? Yeah? Period's the same. Anything else? Yeah?
Domain.
Mm,
No, actually,
well,
you can still accept the asymptote.
you could still write the same thing, but what would be different?
Yeah.
The asymptotes would be different. They would, instead of a pi over 2 and a 3 pi over 2, you'd put a 0 and a pi. So asymptotes would be different, which technically makes the domain different. Period is the same. Yeah? Range is the same. Yep. So range and period would be exactly the same. So I'm going to skip example 4. All right, let me see where we're at here. All right, so it says find the period and the asymptotes of cosecant 3x, and then show a graph that has 2 cycles. Okay. What's the formula to find the period of cosecant? Yep. Perfect. And what's b in this case? 3. Okay. So there's your period. Find the asymptotes. Now, we've got to be careful because we're transforming them. Okay. What are your first 2 asymptotes for cosecant? So I think in my head, I'm like, all right, cosecant, it's 1 over sine. Where does sine cross the x-axis? Yep. 0 and pi. So off to the side, I have 0 and I have pi. But what did I say you have to set them equal to when you do a horizontal transformation? Set them equal to, yeah. Set them equal to the argument. So each of these asymptotes is going to be affected. They're going to be horizontally compressed by a factor of 3. Well, if you had an asymptote at 0 and you compress it by a factor of 3, where does it end up? Something's at 0 and you compress it 3 times as much. Yeah? That one doesn't move. If it's at 0, it won't move. So your first asymptote is still 0. But the second asymptote was at pi. It's going to be horizontally compressed by 3. So it ends up at pi over 3. Those are your first 2 asymptotes now. And in general, you don't have to give me a specific number, but for now, in general, how often does an asymptote repeat? Every period. Well, we have the period right there. So plus that asymptote, and technically you don't need the 0 because 0 plus 2 pi over n is just 2 pi over n. And same with this one. Now, is that kind of a long way to describe the asymptotes? Yes. You could merge these 2 together and say one thing instead of 2. But most people just find it simpler to just say 2. Okay, and they want to see 2 cycles. Okay. How big of a window is 2 cycles going to be? Yep.
Is it going to be 2 pi?
How much is 1 cycle?
Is it
4 pi? How much is 1 cycle? What's the period length in this problem? Yeah? 2 pi over 3 is the period length. So what's double period length?
Oh, 4 pi over 3.
4 pi over 3. So the easiest window you could set would be 0 to 4 pi over 3. Okay, remember when you type in cosecant, you're going to have to do 1 divided by sine 3x. That's how you have to type it in. And if we did this right, we should see 2 U shapes and 2 N shapes. That would be 2 cycles. There's 1. There's 1.5. There's 2. Perfect. That's 2 cycles. And we didn't even break a cycle in half. If you do, not a big deal. Question on that one? All right, so it's easy. So the last thing is basically solving trig equations on the calculator. The only difference is, I think in this section, instead of just writing that there's one solution, we're going to describe all of them. So we did this on the last test. The only thing is I only had you write down one number. But really, if you had a sine wave, let's say you set that equal to 0.5. How many times is the horizontal line and the sine wave going to cross? Yeah?
Well, it's going to cross an infinite number of times because it's always going to hit it like twice every time or every period.
Yeah. So all you really have to do is find these 2 answers and then tell me that those 2 answers repeat every period. Yep. That's all you have to do. So if you can find one solution to a trig equation, then you can find infinitely many. So let's say that you use the graphing calculator, you calculate one of the intersection points, and you get B. That answer, B, is going to repeat every period times n. And remember, n is an integer. So that's the only thing different about doing the intersects on the calculator this time. You have to find what they are and then put plus the period times n. And you don't have to use n. You can use any variable as long as you understand it represents an integer. Let's find this one. Find all. That's the key that tells you you need to do this. If it said find all answers between 0 and 3, well, that's different. Now you only have to find the answers between 0 and 3. But I want every answer to this equation, all of them. So let's start with what's going to go in y1. Can somebody tell me what I'm going to put in y1 and how I would type it? Yep.
Over cosine.
That would be secant. 1 over cosine.
That is a 1 over sine.
1 over what?
Then it's still 1 over sine.
1 over sine. So we got 1 over sine in y1. Okay, what's going to go in y2?
The negative 1.6.
Negative 1.6. And so you don't get confused, set your window to 1 cycle. Then you can see all the answers that you need. What's the cycle length or period length of cosecant? No transformations at all. Yeah? 2 pi. So set your window 0 to 2 pi. Now you're not looking at anything you don't need to. Whatever you see for intersections on the screen, you need to write them all down. Okay? So 0 to 2 pi. And it goes up and down forever. We just need to make sure we'll see negative 1.6. And we will. So how many answers are we going to get per cycle?
2.
2. So second, calc, intersect. Okay, so our first answer, these are just rounded, 3.82.
The second one is 5.61.
All right, thank you. Now, what you've done up to this point is you've found two solutions. You have not found all. So what am I going to put on the top one to represent this solution forever? Yep,
Plus 2 pi n.
plus 2 pi n. So now you've represented that solution repeating left and right forever. And what about the bottom? Same thing. That is how you find all solutions. I don't think we need to go through example 7. I'm just going to ask you a couple things about it. If you graph tangent and you graph 2.5, how many times will a horizontal line cross the tangent function per cycle? Think of what tangent looks like. Just once. Okay. Tangent looks like this. So you'd only get one answer per cycle. You would find that answer. Write it down. And then what would you put on the end to represent that answer repeating forever? It's not 2 pi n. If you put 2 pi n, it doesn't work. Yep. Pi n, yes. Yep. So this one would have less answers per cycle. It only has one. Secant and cosecant generally have 2. That's pretty much section 6.4. Okay. Yeah.
So that's one cycle. That's the black box thing. So
Yep, that's one cycle.
so the two asymptotes. Would you say for the test that we need to like say it belongs for
No.
the two? Like what are we supposed to do? Say for like where it belongs? Because you say they can't claim both because like those asymptotes are like held by like others.
Yeah, so you just have to understand the concept that there's only one asymptote per cycle.
Okay.
Not really where it belongs to. Just, yeah. Yep. All right. So that's problems for tonight. Okay, on 352. So we will go over that first thing tomorrow, and then, as I said, I think this was the hardest section for the week. I think you'll find tomorrow and Wednesday easier. And remember, Thursday is a review day.